All right, so let's back up to here. Um, Today we are going to go over laws of logarithms, properties of logarithms. (7 a.m.) Tomorrow at 7 p.m. I'll be taking my daughter to basketball. Is there something you would like me to do? Or you having a little party at halftime? Awesome. Maybe I will come and check it out. Sweet. Sounds fun. All right. Laws of logarithms. Log base a of a times b is equal to the log base a of a plus the log base a of b. So what that means is you can take a single logarithm and you can expand it into two logarithms, or you can take two logarithms and put it together as one logarithm. And we use this addition multiplication piece. Now you may ask, why is that? I can't show you the proof right now, but what I can say is that logarithms solve for exponents. So if you think about it, if you were to take x to the third times x to the fifth, what would you do to the exponents? You would add them together, and this would become x to the 3 plus 5. So you can see that this is an exponent, and this is an exponent, okay? And so you would add those two together. So that's why the multiplication separates into addition. That's one way to think of it, okay? So if it's division, it would be subtraction. So log base a of a minus log base a of b. And just note that the base has to stay the same. And if you take a power to a power, you would multiply. So this c can move out front. You should remember this a little bit from last year, hopefully. But it's generally a point that gets a little bit confused and lost. And so like, if you could make that stretch, I mean, you could just call somebody anything then, right? So anyway. So if you have log of 5 times 3, we can expand this into a logarithm so we don't have a product or a quotient or a root or a power. So it'd be the log of 5 plus the log of 3. So we're not trying to simplify it, we're just trying to rewrite it. And rewriting it is important. In mathematics, a lot of times we can make life easier on ourselves if we know how to rewrite. In fact, I would say that's one of your biggest limitations is knowing how to rewrite things to make life easier. And so hopefully we can learn to do that. Now, letter B, this is where we really got to start to think about it. And I'm convinced that this is the best way to teach it. But you're going to have to slow yourself down a little bit and just think about it, okay? In order of operations, would I do my powers first or would I multiply first? I would do the powers. And after I do the powers, then the last thing I would do is I would multiply together, right? So that means that the multiplication is the first thing that you undo. So you do it in reverse order of operations, okay? Since multiplying is the last thing you would have done, that's the first thing that I undo. So I'm going to rewrite this as log of 3 plus log of 4 squared plus log of 5 to the 6th. Now what can I do with those exponents? Log of 3 plus 2 log of 4 plus 6 log of 5. So you just move those exponents out front. There you have it. Try letter C on your own. See what happens. Now you're making stretches. Mr. Clog. Very good. as you work this out, I'll work it out two different ways. So either way, you should come up with 3 log of 4 minus 3 log of 7. Now, here's part of how you know whether or not you did the problem correctly. And these are very important parts to pay attention to. We'll use it later on. First of all, is the 4 or the 7 or both being taken to the third power? They're both. So if you notice, I have a 3 out in front of both of them. That's one way to know if your answer is correct, is to think of, where is the power applied in that expression? It's applied to both of them. Also, if you look at this, this is crucial. If I have something in a numerator, say x squared, and denominator, say x to the 5th, that would be like x squared times x to the negative 5th, right? So if it's in the denominator, it has a negative exponent. If it's in the numerator, it has a positive exponent. So since the 4 is in the numerator, it has a positive value. Since 7 is in the denominator, it has a negative value. If that's not checking out each time, then something's wrong. Okay. All right. Next one, we have the square root. So I'm going to write it as log base 3 of the quantity x squared minus 5 to the 1/2 power. Yeah, why not move this 2 right away? Why'd you choose to move the 1/2? It is the right decision. And in the order of operations, you would square something, you would subtract 5, and then you would take the square root. So since that's the last operation, that's the first thing that you undo. So I have 1/2 log base 3 of x squared minus 5. Now, a lot of people would like to try to do something with the x squared minus 5, only we really can't. And, you might even want to move this 2 out front. You can't do that. And here's why. In order of operations, I would square something, then subtract 5. So you would have to deal with the minus 5 before you deal with the x squared. Is there anything that tells us we could rewrite subtraction? No, there isn't. So therefore, this is complete. You're done. Letter E, same properties of logarithms apply to natural log, just because it is a logarithm. It's a logarithm of base E. Anybody identify in terms of order operations what the last operation is here? Division. Very good. The division sign is what separates these two expressions. And so division is the first thing I will undo. Natural log of 2x to the 4th minus the natural log of x minus 2 to the 3rd. Bye. So, let's look at this one right here. It looks like I have a 4 that can move out. It looks like you need to separate the 2 and the x to the 4th. What should I do first? Should I do with the 4 or the 2? 4, why? Yeah, reverse order. So if you think of reverse order, if I plug something in, I would take it to the 4th, and then I would multiply it by 2. So that's what I need to change first. So I separate that into 2 pieces. Now I can move my exponents out front. So some people really don't like that. And I will say that if you have the natural log of the quantity 2x to the 4th, then you would move the 4. And it would become 4 times the natural log of 2x. And then you would have to separate the 2x part. So that's the difference. See that, Terry? Okay. All right. You're going to try this last one on your own. And it's not real easy, but I do want you to keep in mind some of the things we've talked about to check your answer. And I also want you to know that that is that quantity to the 1/3 power. That's what that cubed root means. So go ahead and see if you could rewrite it. And I'll slowly work it out. And you can then check your answer. And there are about 4 different ways of doing this problem. So don't be surprised if you see something that doesn't match what I have. Either one of those answers would be acceptable. So somebody make a mistake that they want to talk about so we could discuss some points of confusion. Yes, Lally. Okay, so in the second part, what I did is I distributed the 1/3 all the way through. Now you don't have to do that, but when I distributed the 1/3 and I got times 2, I got 2/3. So if you want to leave the 1/3 out front, or if you want to put it all the way through, that's fine. What I like about having the 1/3 all the way through is that you can see that all of these are being taken to the 1/3 power. So you see it very well there. Yes. Okay, so you left it as natural log of 2yz. Okay, so that you have to expand because you don't want a product, and so that's how we get rid of it. A lot of people don't, they maybe have natural log of 2 plus the natural log of y plus the natural log of z, and that only works if you put the parentheses around it, but you will have to distribute that subtraction sign through. Remember, if it's in the denominator, it should be negative, and if it's in the numerator, it should be positive. And so that's one check that you can do. Anybody else? A question or a thought? If you'd like to leave the 1/3 factored out, that's fine. Either answer would be acceptable. Anybody get the problem all right? Oh, wow. All right. Star quality. Way to go. All right. So now what I'm going to do, and this is probably a more useful opportunity, is to rewrite as a single logarithm. And as a... Right? Yes. Okay. Well... I have the opportunity to see ahead of you guys, and so one thing that often comes up is when we get to a problem like letter C is people really don't care for the ln thing. They're like, what is it? And I will say that we really need to work through that. Natural logarithm is the same thing as log base e, and I will tell you that when all of you are taking calculus next year, because all of you will, right? Every single one of you can take calc at college or with me. And the fact is that when you take calculus, when you have a choice between using log or using natural log, you will choose this one 100% of the time. Trust me. It is so much nicer when we work with it in calculus. And so there's a reason why natural log is used, and we just kind of need to get rid of our distaste for it. You know what I mean? So, well, kind of like certain jelly beans. Anybody have a certain color jelly bean? You don't like the, yeah, yeah. So, so now we want to write as a single logarithm, and this is the useful skill in calculus. So I have a log base 2 of 5 times 7, which is 35. So a lot of people instead might write log base 2 of, say, 12, because they would add them together. Okay, so Gina, you did that? Okay, very normal, okay? Okay, so YouTube. So my class laughs when they make mistakes as though nobody else would ever make that mistake. It's so dumb. Very common mistake, okay? Don't worry about it, all right? Now, here's a little trick that a lot of people maybe don't see, is that when I see divided by 3, in my mind, I see, well, that's multiplied by 1/3, and that's important because that 1/3 can be used as an exponent. So that's kind of the first lesson about this problem. And then I can move the coefficients out front to be exponents. And what is 3 squared? It is 9. And what is 64 to the 1/3 power? 4. And so now I can rewrite this as the log base 5 of 9/4. Very common answer from students would be log base 5 of 9 divided by log base 5 of 4. Notice the directions. Single logarithm. You know your answer will have just one logarithm, not two. Don't do that. Common mistake on the test. I get angry. I start making everything red. Yes, B. Rodden. What? No, you don't. That'll be fine. Base? Yes, without a doubt. If you had, no, that's okay. It was in the notes when we started. Log base 2 of 3 plus log base 3 of 4. You cannot say that that's log base something of 12. That is not. Well, I suppose we could probably figure out something that would actually work there, but that's not within our, no. So you try C on your own. Try C. I know. And so instead of writing 3 letters, we'll write 2. Don't change anything. Just continue to do it like you did all the other problems. It, it, if you don't like ln, just write log and put a base E. Braden, okay. Can you ask your question again? Root of 2 on the top. Can somebody tell me why the root of the 2 belong? It's positive. The 8 is negative. Think about it like this, Braden. I could rewrite this as natural log of 16 plus the natural log of the root of 2 minus natural log of 8. That's the same as what I have there, right? So I multiply because there's addition. I divide because there's subtraction. Yes, that's absolutely fine. So what Justine did, which is absolutely fine, is Justine dealt with this first. She saw the subtraction, so she said, I'm going to take 16 divided by 8, which would be the natural log of 2, minus the natural log of the root of 2, which gives natural log of 2 roots of 2. So that's another way, or whoops. So that's another way to think it through. Somebody else have another question on that problem. Make a mistake. Okay, then let's do the last example before we get to easier stuff, okay? Yep, the stuff at the bottom is easier. So I'm going to start by distributing the 3 through. I'm going to have 3 natural log of x plus 1 plus 3 natural log of x plus 2 minus 6 natural log of y. So now I will take the coefficient out front. Yes. So we'll deal with the y now, and that will be as we take the exponents and move them, or the coefficients and move them up as exponents. So we have the natural log of x plus 1 cubed plus the natural log of x plus 2 cubed minus the natural log of y to the 6th. So now which one's going to end up in the denominator? The y to the 6th. So you will have 1 logarithm, not 2, not 3, x plus 1 cubed, x plus 2 cubed, or y to the 6th. Now, some people may rewrite that, so I will admit that when I was your age, this is how my answer would have come out like this, because I would have chosen to deal with the 3 at the end. And so either one is fine, but you know, it's a free country. Do what you want. Yes, these are both the same. Your either answer is fine. You have one logarithm, and both answers are equivalent. Carter, was that? Did you have a question? Okay, I thought I heard. Okay, very good. Okay, so this might be something that you and what I think is really good is if you see a problem, if you're not real sure on it, you know, to go back and try it later on from your notes. I mean, you get the same thing, you feel better about it. Or you know, watch a video again and see if you can work through that a second time. But sometimes first time through is challenging. So let's evaluate these expressions by using some of our operations that we did and changing some of our bases. So we have the log base 2 of the root of 32. I'm going to rewrite this as log base 2 of 32 to the 1/2 power. So what can I do with that 1/2? All right, so I have 1/2 log base 2 of 32. And now I'm going to do one more thing. I'm going to create 32 to have a base of 2. So I have log base 2 of 32 would be 2 to what power? 2 to the 5th power. And so as you can see, very good, Rhiannon. So, yep. So those cancel, and I get 5 halves in. You multiply them. Because it's 1/2 times whatever's left here. Tristan? Good? Okay. The next one, log base 5 of 100. I don't know what that is. I know that 5 to the first power is 5. I know 5 to the second power is 25. I know 5 to the third power is 125. So it must be like, you know, 2.7 or something like that. Who knows? But if I combine these together, I could say it's log base 5 of 25. Because I use my division property. Yep, so log base 5 of 5 squared. Oh, so if we have log base 5 of 100 minus log base 5 of 4, we divide them and make one single logarithm. Yep. Christine? What should I do for letter C? Put the 4 in the front. I wish I was as smart as Rhiannon. Gotta ask the question. Oh, so, okay. Well, good. I'm glad you were going to try it ahead of time. I'm going to take that 3, and I'm going to move it right here. I get e to the natural log of 5 to the 3rd power. Now, what is the base of a natural logarithm? Yes. I took 4 times 3 because log base 3 of 3 to the 3rd, it is 3. And this is 4 times whatever that is. Good question. So natural log can be written like this. This could be written as e to the log base e of 5 cubed. And so these are equivalent expressions. And as you see, base e and log base e are inverse operations. So they can cancel. 5 to the 3rd is 125. That's your answer. So logarithms, not used a whole lot, but you can see how they have some interesting properties. Okay, our last example. Please flip to your very, very back page. And if you look at the very back page, you can see that in the bottom right-hand corner that we have laws of logarithms, and we also have what we call a change of base formula. And so these laws of logarithms, you should always keep in mind. They're written there in case you can't see them in your notes or something. A lot of your logarithmic properties are right here. For example, you can see that the natural log and the e cancel in those situations. Here, the log base a and base a cancel. These are x. Some of those important properties. This one would be for Rhiannon. Natural log is log base e, so always a nice piece to keep in mind. But change of base formula, sometimes there's bases that we don't like. And for the first example, we have log base 6 of 14. We don't really like that because 6 to the first power is 6. 6 to the second power is 36. So 6 to what power is 14? Like 1 point something, I guess. But in our calculators, they don't have a base 6 operation. They have a base 10. They have a base e, but they don't have a base 6. So here's what we can do. Log base b of x is the same thing as log base a, so you could change the base to whatever you want to, of x divided by log base a of b. What that means is, what are the two bases you think we generally change our stuff to when we use our calculator? 10 and e. So if I change it to 10, we end up with just the log of x divided by the log of b. And if you change it to a base of e, you would write it as natural log of x divided by natural log of b. Yes, you should have seen a change of base formula last year. Terry shoulder pouty face. Very good. Okay. So let's see what we get. I have log base 6 of 14. So we know it's going to be 1 point something. So what I will do is I will do log of 14 divided by the log of 6. Or I could do the natural log of 14 divided by the natural log of 6. Whichever one you would prefer. Either way, you're going to come up with an answer, and we will express our answer to 6 decimal places.
Wow.
Please make sure that when you type this in, you use your parentheses. And I get 1.4728886. Okay? What I'd like you to do is quick do the next two. When you get an answer, put it up on the board, correct to 6 decimal places, and I'll show you why we do to 6 decimal places. So, quicker you get it up on the board, quicker we get to our assignment. Thank you, B. Rodden.
She said she couldn't see it.
Very nice. All right. Good job. Trav can do it. We believe in him. Lexi, I like what you've done with your hair. Not figuratively. Literally. Not metaphorically. Not symbolically. Not grammatically. Not historically. Literally. Okay, now, to those of you who are a little bit perturbed by these 6 decimal places, try to understand my point. Here's my point. We take 14 and I raise it to the 2.8 power, and I get 1,618. Is that 1,652? No, it's not even close. Then I take 14 and I raise it to the 2.0 or 2.807, and I get, well, we're closer, but you get my point that by the time you get to 6 decimal places, 2.807723. Well, that's a nicer answer. So that's why 6 decimal places is a better result when you're doing with exponential and logarithmic functions. Your assignment. It is odd. Some of these problems will go quickly, some of them will not. I need to encourage you. I gave you the odds for a reason. Why do you think I gave you the odds for a reason? If you dare just write down all the answers out of the back of the book, I will hunt you down. And we will have a nice conversation where I'll put the fear of Mr. Gantz into you. So, fear of the clock. Boy, you guys are, I'm done with you. I'm done. You can say bye to the people.
Hi, people. So, Brayden, so logarithms, they're not the easiest thing, but if you hate natural logs like me, then just change it to log E because that's a lot easier because it sounds like loge. Okay, bye.
So, YouTube Nation, I will visit Rhiannon next year in college when she's trying to do calculus with logarithms. And instead of taking the derivative of natural log, I'll make her do the derivative of log every time instead and see how she likes it then. So. Yeah.